Good afternoon and welcome to TI Australia's 2020 VCF Mathematical Methods Term 3 Revision Exam Style Questions. My name is Chris and I'm a current teacher of Math Methods, and welcome to Part 5, the Public Library. So I think everyone's been waiting for this one after the last one about widgets. So what are we going to look at today? Well, we're going to create user-defined functions again, and then we're going to utilize the public library and the functions and programs on the calculator. We're going to solve some exam-style questions, and we're going to discuss some advantages and disadvantages of these methods that we're going to try and look at tonight. So why do we use public library UDFs? The whole idea about this is to save time and keystrokes when solving questions. We can pre-prepare them before an exam or assessment task. And as we're talking about exam-style questions tonight, they're written for past similar exam-style questions. And we can, most importantly, and the important thing of this is just like the widgets from last session, part 4, we can import them into any open document that we've got. Okay, so we've got question 1. You'll notice that we're looking at similar exam-style questions, and from last time we had a very similar question to this, and the only thing that's changed is the function that's in there. So we've got the amount of drug d milligrams in the bloodstream at time t hours after it is administered is given by d equals 2e to the power of minus 0.5 t between 0 and 2. The average amount of drug in milligrams present in the bloodstream over the first 2 hours after it's been administered is closest to one of those values. So what are we going to do to work this out? So just as we were talking about last time, we would set up some sort of exam file, and then when I start the exam, I'm going to come through and do it. So we'll just go over a quick way of doing that before you get into the exam. So Control, and I'm going to hit Control and New, so new document in there. And what we're going to do this time is we're just going to press Escape, and I'm going to go and look at the page sorter, Control up arrow, problem. I'm going to highlight that, and I'm going to use the Microsoft command Control C, and then we're going to go Control V, and Control V, Control V, Control V, and keep going until we've got the desired number of questions that we've got that we want. And then what I would do is I would pre-save that in there, and so to save that, so we go Doc, File, and Save As, and we just call that somewhere in our thing, and we might just call it exam. Okay, so that's what we'd do. Okay, so it's saved, and then we come back and we'd start to do the questions in here. So now, just an annoying thing about some touch screens there, it's just got rid of one of the files that I wanted, so I'm just going to have to open that up again. Okay, so there's our file. Okay, so going back to our question, so I've opened up my exam file now, and I've just added some information at the top statement referring back to the PowerPoint. And what I'm going to do is I'm just going to solve this if I would at the exam, and then we'll come back and discuss it. So I'm going to go to the catalog, and then I'm going to go to this file. We're talking about the average value function. It is there, so I'm going to select that. I'm now going to enter the function which we're talking about up here. And because I got it there, I'm just going to go Control Copy and paste it in, Control V. And the other thing, well, we're wondering about what the syntax would be, and that's the whole thing about it. For these things, if you write them, you have to wonder about the syntax that is there to do it. And then, so you've got a bound reference that you can take into the exam. So one way of doing this would be say, I've got this average value function. that's listed there. I've got the syntax, which is the function that I have to put in. Notice that I've got a little X here. Now that's a reminder for me to say I need this function in terms of X. So I have to put an X in there. All right, so if I go to my bound reference, I look up the code that I have for this. The next thing is the low X value, and the one after that is the high X value. So I've gone to my bound reference, double check that it's okay, I press enter. Now we get 1.26. So going back to our PowerPoint, 1.26 would be answer C. Okay, so it's answer C, which is there. So creating a public library UDF. So you would open up a new document and add a calculator on Notes page. You would add all your UDFs, must be written in this problem 1 that you have. So if you put it in problem 2, when we do a few extra things to it, you won't see the functions you've written. We enter the syntax, the following syntax, which is there. So you have to enter this syntax into our function. Okay, that's the first bit we've got to do. So there's our syntax. So let's take a memory of that one. Have a quick look at it. We'll go back to our calculator. It's here. So how is it that I could do that? So the first thing, we'll do it in this file here, in our exam part 5 file. So actually, no, I'm going to make another file. It's in there. And let's just go here. And there's our new file, and we'll go calculator file here. And we need to see the syntax one more time. So let's just go back to the syntax and have a quick look at it and remember it. There it is. So I've got to get this define lib pub. Public library is what this means. And I've given it average value that's in there. And I've said X as a reminder about the variables in there, as I mentioned before. So let's start putting that in. Okay, menu. Now under actions, we know define, but if we keep going down to number 7, we see that there is the define libpub number 5, and then we're going to put in our name of the file that we're going to call it. Now, you type in what you remember, whatever gives you a key feature that's in there, and I just used R as the value which is going into the function. You pick whatever you will remember. And then we're going to bring up our template, and it is 1 on B minus A. Plus and times. Now this is why you pre-prepare all these, because, and remember, and you only want to call it, you saw how quickly it was to just call these in before to run it. And that's the whole idea of it. We do this quickly. And we put in the variable, which is X in there. So that's why we had to have the variable X, because it's DX there. So we press done. And it's always a good idea when you do these that you actually run them. So in the file that I've written it at the moment, we'll notice that there is a var button, which brings it up, average value. And let's just put in any function just to test that it works. Let's just put in X squared. And go back and put in a couple of values, 2, 4, that'll do. And you just make sure it works, and then you test them. Now, it's really important that you test these significantly throughout different functions to make sure it's actually worked. The next thing we have to do is we have to save this file. So if we go doc, file, and save as, what we have to do is put this in my library folder. So we go down till we find my library, and open that up, and let's just call this MM. So call it something. So this file MM will have all my formulas that I want for this subject, and I'll put it in there. So that's MM. Okay, so it's saved. And next, what we're going to do is we're going to go back and do one more step. So let's just go back to our PowerPoint at the moment. Okay, so we've got our syntax in there. It's done. Files have to be saved in the mylib folder. File names, very important. Maximum of 16 characters with no spaces. Really important, no spaces, otherwise it won't work. Now, if you're finding that it's not working for some reason, as I found with one of my students, guess where he had the space? He had the space at the end of the variable name, and it took me a long time to work that one out, and that was just before he sack. He says, "Sir, I don't know what's going on, it doesn't work." And the third step we've got to do there is we have to activate these. The CAS does not know your functions you've written until we've activated, so we've got to go doc 6 refresh library. So let's go back and do that. And the next thing, doc, and number 6 is refresh libraries. Okay, all good. So let's go back to the exam file that I set up here. And if I now go to my catalog, and we'll see the MMs there, and there's my function that I had, that I just set up. And all you do is you click that, and it comes up, and we could just go through and just to double check that it works, highlight that in the history, press enter, comes down there, press enter again, and we get the same answer. So your function's working, and it's all good. Okay, that's great. All right, so what's next on our agenda? So we saw this before. I just showed you about accessing the public library there. So just to refresh our memory, we've got to select the catalog. We all know the library, the book, but we go to number 6 is there. We click on that TNS file as we just did, and once we click on that, the plus button there, we find that any UDS that we find in the public library come up, and then we click the appropriate one to insert it. We just did all that. Okay, the next question is the average value of the function with the rule fx equals x squared minus 3x over the interval a from a to 5 inclusive, where a is greater than 0 is 5 on 2. So we know what the value of the average function is over that interval, but we have to work out the value of a. So that's what we're going to think about. So I hope you've all downloaded the worksheet beforehand and have already got an answer, and we'll see how we're going with that one. So let's go through and try and solve that one. Okay, so there's a summary of our question. Right, so let's call up the average value function that we just calculated in our MM. Okay, so there's our average value function. So I'm just going to type or copy and paste that in there. So if I highlight it in the history and press enter, it goes in the appropriate spot that's there. I then, if we remember our syntax, it was the interval. So A we can put in there, and then we're going to put in the 5, and we press enter. We now get this formula that's written in there, and it's our average value in terms of A. Now what we have to do is we're going to solve that, new algebra, and solve. And if I go up arrow in the history and press enter, it comes down there and it's pasted in. And then we know that equals 5 divided by 2. And we want to solve for the variable a. And we get two answers. A is minus 5 on 2, or a is 2. But we know that the answer would be a equals 2, because in the question we were told that a was greater than 0. So there's our answer for that question. It's 2. Okay, let's move along. Okay, let f be the function which has a domain of real numbers mapped into the codomain of real numbers, where fx equals minus x cubed plus 8x squared minus 16x. State the values of x for which the graph of y equals fx is strictly increasing. Okay, what are we going to do for this one? So, matrices and UDS. Well, believe it or not, matrices can be added into your function so you can get more information coming out. So we can add a calculator page or notes page, doesn't matter which one. For most of the UDF style ones, I actually prefer the calculator page, mainly because when you paste it in, it doesn't define that variable fx or whatever that may be associated with the rule. So I prefer a calculator page, but it can be done in either. So we have that syntax which is there. So we'll just do a quick little thing about how we can do that. Okay, let's move along to our next page. Okay, so there's our question. What are the x values that are strictly increasing for that function? Now, I'm actually on a notes page there. So if you remember, we have to first put it in a math box, an equation box. So insert, and if you notice, the shortcut is Control-M. So all the time when I do this, I just say Control-M is what I do for these, and find that that's a good way of doing it. So let's call it strictly. Okay, now before we do that, we had to go back again and put in our define with hub. So remember what we've got to do now. Calculations, actions, it's the same menu that you get before, and calculations, sorry, define variables. And I don't normally use this one that's here. I do this, as I said, on a calculator page. So same, slightly a little bit different there, but we still get there. And our function is strictly, we've got there. And what's the next bits that we're going to do? We're going to put some sort of memory thing in that we have for that. Notice that the title is not bold yet. So we're going to say, well, this function again will be in terms of x, and I have to input the rule. So I'm just going to call it A, and then we're going to go equals. Now we have to put in a matrix template. So bring up your templates, pick the matrix, and I want to go for 3 columns, and 3 rows and 2 columns. So put that in there, and there's our matrix which is in there. Now the next thing we're going to do is we're going to put in some comments. So a way to put in some comments is hit the question mark tab, and we put in that. Now that's a touchscreen thing, so don't worry too much about that. And we're just going to say the derivative. So if we had to show some sort of working, the derivative would go first, that we could work out. The next thing, and we'll put in, if you want to work out the increasing part, and then to save that happening again, I'm just going to copy this and paste it in and change that to decreasing. Okay, now the formulas we're going to put in, which are there. So what are we going to do? Well, we're going to hit our template for the derivative, which again, shortcut is Shift minus, and all we want to do is have the variable is x, and put in the value of A there. And then the next thing, what we want to do now is solve. So if you like, now I would do these all on your computer software, because it's much easier to do that. And again, from on the computer, I can just go Control-C and then paste this in there, Control-V. And for increasing, we know that that has to be greater than or equal to 0. And comma x. And again, save time. If we're on the software, we can just copy this and paste it in. Now, tonight's all about learning how to use the software. Over the last few sessions that we've run in the earlier parts, we've gone through a lot of the theory of this. So please go back if you want to go over the theory to those sessions that are there. Okay, here we go. So now we put it in, and there's our function that's there. The next thing that we'd want to do, now just note that in this, what I actually did was here is I actually did it in my exam part 5 file rather than my file that was here. So if you do this, and on the software, it's a good way that you can do these things is if I press escape, it comes up with menu. I go back to my other file at the bottom, and I can go through and click that orange line that's up there and go Control C, and then I can go back to my MM file and I can go Control V. Okay, again, you'll notice that all the math boxes have been turned off. So I would go inside the math box and I'd press enter, and it's now activated and done. And what I have to do now that I'm in my MM file, I would then go save it, Control F to save. I would have to go back as we did before and go Doc and 6 refresh libraries. Okay, I'm going to go back to my exam file, and I'm going to go, now just ignore that we've got this define lib pub there. I'm going to go to my catalog. I'm going to go to my MM file, and there's my strictly increasing one. I'm going to put that one in there, and then all I have to do now is go up and type in my function. And I'm going to copy it from the top and paste it in. Okay, and then enter, and we get our answer. So, recapping our question, top of the page there. So for fx being that cubic, what are the values, x values, which they are increasing? We go to our table there, and for increasing, x is greater than or equal to 4/3 or less than or equal to 4. Okay, good. So we can see that matrices allow us to output more information than just one thing. So they're a good tool to have. That's there. Okay, question 4, part A. Let G be the function which has a domain of real numbers mapped onto the codon domain of real numbers where it is that cubic that is given. We are to determine the coordinates of the stationary points of the graph of y equals g of x. Okay, so that's our idea we've got to do. So stationary points. Now, in part 4, we did widgets, and if you were going to, you could go back and do the widgets that's there. But let's have a look at another thing. So we've got to work out the stationary points for this part. So let's see what we've got in our catalogue. So I'm going to go to, this is one that I did earlier, and we're going to go down, and we're going to look at something that says ST. So there's a few functions in there that we've got. And just a note for you guys, I will give you all of these functions. This file will be in the Google Drive. All right, so I'm going to pick SP of X. And remember, the X was that the variable going in the function was X. So I select that, and I'm going to come up and type in, or in this case, I'm going to go Control C and then paste this in here, Control D, and press enter. And there's our answers. So our answers are X equals 1 and Y equals 9, where X equals 3 and Y equals 5. Okay, so there are our two stationary points. Done. Busted. Okay, the next part, 4b, says find the shortest distance between the two stationary points. Okay, so that's the next thing we've got to do. And we're all thinking Pythagoras' theorem, something like that. Sounds pretty good. All right, but we're going to do this in a slightly different way. We're going to go and look at functions. And in order to do this, we add in a calculator page. We're going to add a function using the program editor. So programs. And we're going to add a file name and allow library access. So the instructions are there. So must do this on a calculator page. We're going to call it distance2 2p underscore f, f being that it's a function. So when I scroll down my list, I know it's a function. And then we come up with this menu here. The next thing we're going to do is we're going to put in this input is there. Okay, so we'll quickly go through and have a look at that. So this is what we've got to do. Now, comments. So the good thing about these functions is this comment that is here, we can actually do that, and that will actually display when we go to the catalogue, just like when you're looking up any function in the catalogue there, when we go to the public library, we can get this to display, so it gives us an idea of what's going on. And then Control R runs the function inside. So let's have a look at this one. And let's go to our MM file. So I'm going to put in a calculator page. So Control R. That's what I'm used to. And menu, and we go to Functions and Programs, and the Program Editor, and we want to make a new one. And we're going to call this one DIST underscore 2P. Well, I'll do the 2P before I do the underscore. 2P stands for 2 points. So I have 2 particular points. It's just what I've made for myself. You make up your own name, which you like. And F was for it was going to be a function. So we don't want a program, we want a function. And we want to have library access showing the catalog. And we press OK. And that's what we get. It's over here. Now, I'm just going to split this, make this page larger so we can type in the C a bit more. So Control 6, remember, for page layout. And just to expand it out. And we're now just going to type some things in here. Now, when we have 2 points, we have x1, comma x2, comma. Now, do you want it that way? Well, some people do. When I was talking to my students at school, they liked it that way. But I think it's better to take the points because we read the points as x1, y1, and x2, y2. So I think that's a better way of doing it. And when we come down to this next bit, I'm going to put in a comment. So, menu, actions, and if we have a look at number 8 is comment. So we put in a comment and it puts the C, just like if you did it on a calculator page. And what I'm going to do is I can, in the same way if I'm on the software, very easily go Control C and then go Control V. So this is why I use the software. It saves me so much time. And then I'm going to press Enter to bring up the function line. And all we have to do now is put in Pythagoras' theorem. And we put our y2 minus y1. So I hope you're out there thinking about what other functions could we actually do for this. So, and let's go out there. Now, we have to run the function and make sure it works. So Control plus R does that. Okay, and let's just try it out with any generic points. 1, 2, 3, 4. Okay, so we've got the coordinates of 1, 2. That's our first point. And then we have the other point is 3, 4. And press Enter, and that appears to be working. Now again, we've got to save the file. Okay, we've got to refresh the libraries, number 6. Okay, done. We go back to our exam file. Yep. And we go to our next page. So we've got to find, there are our points that we've calculated before that I've put in there. Save a bit of time. And let's go and look at our catalog and our library, our MM. So we scroll down, and there's our distance. Now, when we press it, this time we actually get a bit of code which tells us, it reminds us of what? I don't have to go to my bound reference this time. I just have to look and say, oh, I've got to put in the 2 values, coordinate pairs in that order. Okay, so press Enter to select it, and then we're just going to put in our 1, 9, oops, comma 9, and comma, and 3. And comma 5, and press Enter. Done. And the answer is 2. 5 is the distance between the 2 stationary points. So let's have a look at our next question. I hope you guys are all excited about doing that, and that you're thinking about some functions that you could write for yourself and add to that MM file that is there. So our next question. If function h is defined by that cubic, we've got to find the equation of the straight line passing through the stationary point and the point -1. 6 in the form y equals mx plus c. So just give you a moment to think about what we've got to do. So stationary point, and then we've got this other point, and I've got to work out the equation going through those 2 points, and we start wondering about what is it? Is there something that we have that's in our answers that we could do that by? So let's go and have a look about that. Okay, excellent. So there's a summary of our question. So what have we got in our library functions that we could use this time? All right, so what's Chris got in his bag of tricks? So I'm going to go to this one that I've got here. And we're looking about stationary points. So let's see what we've got down in the stationary points this time. Scroll, scroll, scroll. You might like to just split these up by topics if it's easy to do so you don't have to scroll so far. So I've got this function one which says, so it's a function. I've got to just put an expression in x in that. So press enter to select it. And then I'm just going to copy our rule up here. So if I highlight that and press enter, it'll go into my rule. And then oh, look at that output. Isn't that a brilliant output there? We see that it's obviously a cubic with a stationary point of inflection at 2, 4. Okay, so there's a nice output. So when you get the file, you can go and look to see how the syntax was done for that. And the next thing, we've got to find the equation of this point from 2, 4 to negative 1, 6. So what's in my bag of tricks this time? Let's go through and have a look again. We're scrolling down, and something that might sound like it's, oops, but let's go down to this one here and scroll down. We're talking about something like a line. And is there a line one there? Let's hope so. We'll have to, oh, let's go to this line 2. P is a function. So it says that I have to put in the x1, y1 value and then the x2, y2 value. So let's press enter to select it, and let's put in the negative 1, 6. And then we're going to put in the 2, 4. And we press enter, and voila, there's the equation in the form y equals mx plus c. So it's y equals minus 2x on 3 plus 16 on 3 is the answer to that question. How quick was that? How great was that to get that out coming up by just putting in 4 points? How would you have done it if you wanted to do it going through with pressing all the buttons? Y minus y1 equals mx minus x1. Again, when you get the file, have a look at the syntax for that one. So let's go and have a look at the next question. It is there. Okay, question 6. If f dash x equals the square root of 2x minus 3 minus 1, find the equation of y equals fx given that it passes through the point 6, 4. Okay, so we've got to take the antiderivative, and then we're going to substitute the point 6, 4 in, work out the value of c if we did it by hand, and then see how it goes from there. And that's it. And then rewrite the equation. So that's what I'd do if I was doing this in reading time, the exam. So let's see what we've got in our calculator. Okay, there's our summary. Now, what's in our little bag of tricks that we have here? So, first one up, ADF is a function. Okay, and AD1, my code for the first antiderivative, and it's a function. So it's going to be expression in x. Then I have to put in the x value that's on the antiderivative called capital Fx, and then the y value on the antiderivative curve. It's there. So press enter. So let's do that. Let's put this in. Press enter. Comes down there. So it was the x value, which is 6, and then y value, which is 4. And we press enter, and there's our rule. So the only thing we have to add to that would be a fx equals. So we could just say, look, fx, and then go across, put the equal sign in, go up arrow, press that, and there's our function. It's our function for the answer to that. That's question 6. Done. Okay, so just another little thing to look at. Now, programs, average rate of change. So another way that you could do this, and I don't have time to go into how it is, so I'll put the program that's there, and you have the program in there. So you might like to do an average rate of change program, and you use the program editor, but instead you program, and you add the file name and allow library access just before. Similar screen will come up and you just type in the code required. So it is there. So I'm going to just go across and just show you how it might work. So a program file. So for average rate of change. So we go back to our library, our own public library, and we're looking at something average rate of change, and it's got program, P for program. F would be as a function, P for program, put that in. Now, I do not put, for this one, I do not put anything in the brackets, and I press enter, and it says enter the function. All right, let's enter a function. And now I'm giving you a little bit of a spoiler here for the next question that you guys get to review, so I would hope that you would do this. Let's just put this in this function. There's an x squared minus 1. So it tells me what I've got to enter. Please note that you have to put any powers in with the caret symbol there, and we press OK. And it then says enter the lower value. So let's say for the average rate of change, remember it's the gradient between 2 points on that curve. Let's put the lower value as 3. We then have to put in the higher value or the upper value, and let's say that's 7, and we press OK, and then it tells me there's the function just as a check that I've got the right function, and it says the average rate of change from 3 to 7 is 10. So that's a program. They take a little bit more effort to write. Whether it's of great value to you, a lot of people say they're fabulous, yes, but if we go back over the last few weeks that we've done these things with the widgets and the user-defined functions, I've given you some tools to solve with widgets. We've got UDS on the public library, and the last tool would be a program that you can write. And let's just get back here. So just a couple of things to remember, some shortcuts on that last page. Control M, that's sort of map box select all for when we had the widgets. So all those tools that you had, please go back and try them and use them. And the last thing that I want to say is we come back to the end of our sessions here. This is part 5 of the current series, and I'd just like to wish you all best of luck with the rest of your year and good luck with the exams. And I hope that you actually go through and write your own little public library UDS functions, etc., or even program. And whatever you do as an investment, as you're doing your exam practice, you go back, and if there's any similar style exam questions in there, maybe it will suit a public library UDS. Good luck with everything, and good night.